Hi everyone. I hope all of you are doing great and staying safe. I welcome all of you to a very interesting webinar. I will be your moderator today. I am Hassan Aleem from Pakistan and I am currently enrolled in China University of Petroleum as a master's student in petroleum geosciences. Our guest and speaker for this session is Engineer Ahmed Elzeftawi, who is a very skillful and dedicated person having 34 years of petroleum industry experience with an expertise in coiled tubing, nitrogen services, wireline well testing, well intervention, completion and downhole, covering the Middle East. Engineer Ahmed Elzeftawi got his bachelor's degree in mechanical engineering from Cairo University in 1983. Engineer Ahmed experienced more than 17 countries in his expertise as an instructor, supervisor, consultant, and manager. We warmly welcome you, Engineer Ahmed, for sparing your valuable time for educating us, and we are really excited to have you here. The purpose for this session is to provide you outstanding petroleum education. So guys, make sure you learn the most out of it. Still, if you have any question, write it down in the Q&A section. You can ask anything in compatibility with our today topic. And please don't use the chat box for your questions. Without any further delay, I request Engineer Ahmed Elzeftawi to begin the lecture. Engineer Ahmed Elzeftawi, we are eager to hear from you. Please continue.
Thanks, Hassan, for the introduction. And hi, everyone. Today we are going to talk about completion. And this little word, which is completion, just very short one, but we can talk about completion for 2 months. So today is not about completion course. Actually, we would like to go and look for the completion from the well intervention point of view. Actually, our objective is to provide general knowledge. This is not an in-depth course of completion. This is just to know why we run completion, what is completion, why we run it, and what is the accessories we are used while running the completion, and the purpose of each accessories in a very simple way. But we will not go in depth for any of the topics that we will talk about today. Completion, we will have 2 sessions. One is today and the next one will be after a few days. So what we will go through today and the general types of it. Then we'll talk about some accessories we are using, like an anchoring device, circulating device, and what we call isolation device. And then we'll continue in the next session for the other devices, plus the wellhead itself and the Christmas tree. We say that well completion, it is the hardware of the outflow system and the final stage of a drilled well. Normally, we drill a well, run a casing, and then we run a completion. It is the final stage before we start producing from this well. When we design the completion, our philosophy is to maximize the profitability. This is we do by maximizing the well hydrocarbon recovery and by considering the full hydrocarbon resource life cycle. This oil, which is deep, maybe 15,000 feet away from the surface, we need this oil to get it out, or to be more correct, to get the most of it out to the surface so we can use it in a very professional way, safe and cheap. This is the main reason, because actually the oil which is deep in the well cannot go all the way up. without transportation. Which transportation oil is used? Gas. Actually, if the reservoir is full of oil but has no gas, you cannot get it out naturally. You have to put your hand in your pocket, get some money out of it, pay. You have to pay money to get this in what we call secondary recovery. And sometimes we go farther into a tertiary recovery, which is more expensive process of getting the oil out to the surface. Look at this word, a quality well is a well which contributes over the life cycle in maximum monetary value without compromising its safety and the environmental standards. This is how it looks like if I have a knife cut on the ground like that, and then have a side view. This is what I'm going to see on the side view. We have here the surface, and then we drill a hole all the way down till we reach what we call the pay zone. The pay zone, which is the oil producing zone. Oil, you see on top here, we have what we call gas rock or cap rock, sorry. This rock, which allow us to have what we call a reservoir here. The reservoir containing gas, oil, and water. Gas is the drive media. Without the gas, which is pressurized, no one can allow this oil to go out by itself. The oil needs a drive mechanism, which is the gas. That's why, while designing the completion, you have to be sure that when you drill this hole and you perforate, so what comes out from the reservoir into your production tubing is a mixture of gas, oil, and water. And you have to be smart enough in your design to not let the gas escape out of the reservoir, going through the production tubing all the way to the surface without having in his hand out free. You should cry. You are losing. So this is how the smart designer of completion, when they have the data, they have to be sure that they will never let the gas go alone. The gas has to take in his hand, while traveling from deep in the well all the way to the surface, some oil, the maximum oil he can carry. We have what we call conventional completion, which is the normal completion we are using. It's a standard completion having a lot of accessories, which we are going to talk about. Each accessory is to do a certain function. And you have what we call monobore completion. The monobore completion is a production tube we run in the hole, but without accessories. Why, Ahmed? And if we can run completion without accessories, why we run completion with accessories? This is a big question, but normally we use a monobore completion in wells where the reservoir pressure is very low. So when we perforate, and then we have this mixture of gas, oil, and water start coming out from the reservoir, going up to the well, what lifts these liquids, which is the oil and the water, to the surface? It is in gas. If the pressure is low, that means the velocity is low. And when we have accessories, like the one that we will talk about, each accessories, it restricts the flow, because actually it's a smaller ID than the completion tubing itself. So this is smaller ID. When we have the flow going up, this is smaller ID, this restriction you make, it makes a back pressure to the reservoir. So if the reservoir pressure is not strong enough, it's not high enough, the well will be died. It will be a dead well. That's why in some application, we need to tell the pressure downhole, don't worry. You can go all the way to the surface. There is no restriction in your way. How we do it, this is not the course to talk about it, Yani. But I need you to know that we have what we call monobore completion, where it does not have accessories. And actually, if we need an accessory, we can run it temporarily in the monobore completion for a certain purpose and then remove it again. You don't have to know why or how in this kind of a course, well intervention course. What you see here, it's a single completion where we have Christmas tree on top, and this is the casing, and we have the production tube all the way down, and this is our pay zone. This is where we produce from. This is typical. Sometimes, if you have two zones, upper zone and lower zone, what you see here, we still have one single completion, one production tubing going all the way down. And here we can produce from the lower zone. Why we cannot produce from the upper zone? Because here we have what we call SSD, sliding side door. This is sliding side door, it is a closed door. So you cannot access the production tubing. But here, we are producing from, it is one single completion, one single production tubing, and we are producing from the upper zone only. We prevent the flow from the lower zone by having a plug at the end of the production tubing. You see it here. This is a plug. And we open the SSD, the sliding side door. So we are producing now from the upper zone only. In this example, and the SSD is open. So now we are producing from both zones at the same time. We do this in case you don't need to study the characteristic of a particular zone. So you don't care, you just need flow out. We do the same if we have a dual completion. Dual completion means we have two production tubing, we run it in the same well. So what we have here in this example, we have two production tubing. One we call it short string, which is a short pipe. The other one we call it long string because it's a longer pipe. A short string is to produce from the upper zone. While we have the long string here, it is to produce from the lower zone. And we have this black color, you see it here. This is Parker's. And Parker mainly is to isolate an area from another area. So El Parker mainly is to isolate these flows. In this example you see here, we have two production tubing, but one is inside the other one. What we have here, we have three zones, but we use only two pipes. In this example, what you see is the short string. We are producing from the upper zone and the lower zone and the middle zone, sorry. Why? The long string is to produce from the lower zone only. While here, what we have a short string producing from the upper zone only. And a long string is producing from the lower zone. The middle zone is not produced because what we have here is SSD sliding side door, which is closed. So you cannot produce from the middle zone now. Ahmed, which one we use? Which is the best scenario? Either single or dual? If I answer you this question, I'm dummy. Because to answer this question, you have to give me so much data. And based on that, I can tell you the best scenario for this particular well. As we said, when we run the completion, this tube, these pipes, we run it with a lot of accessories. Each accessory is to do a certain job. Let us talk about these accessories. What you see here, this is the production tube, which is in yellow color, and it is full of other colors. These other colors are the accessories we run. We divided these accessories into 5 groups based on the activity of each group. So first group, we call it anchoring device, where we can put under this name any device we use in the completion for anchoring. And we have circulating device group, where we put under that name all the devices we run in the completion that we use it for circulation. The third group, we call it isolation device group, where we put in this group all the accessories we use to isolate. The fourth group, we call it anti-erosion device, where we put under this name the accessories we use to prevent erosion or to minimize erosion. And then we have group called other, where we put all other accessories we use, which we cannot classify into one of these 4 groups. So when we talk about an anchoring device, mainly you have what we call landing nipples. And if you look at the drawing here, you will find now a lot of landing nipples. Is it 3, 10, 5, 4, 1? I cannot answer you this question. It depends on the design. The design depends on the data you are providing this software. But anyhow, these landing nipple, and please, and you will see here what we call top no-go, bottom no-go. Don't be confused with the word no-go, because some people believe that no-go means nothing will pass through. But no, we mean by no-go, it's a shoulder inside this landing nipple. This shoulder will allow everything to pass through, except the one flow control device, which is whatever valve or plug you are running. You need to set it in this particular landing nipple. It depends on size at the end. So it will allow everything to pass, but it will no-go. It will prevent its particular plug or valve to pass through, because it has to be set on that particular landing nipple. landing nipple we use in the completion, it is for one purpose, which is to receive what we call FCD. FCD stands for Flow Control Device. What is the flow control device? It is any device to control flow, which mainly plugs and valves. Plugs and valves. This is what we call flow control device. I repeat, all landing nipple we run with the completion, it has main function, which is to receive a flow control device. What I said is applicable to all landing nipples we run, except one, which is the last landing nipple in the completion. In our particular example here, you will see it here. This is the one. This one has another main reason. This particular one is mainly to allow you to isolate the reservoir from the lowest possible point, to protect your reservoir from the lowest possible point, allowing you to make any operation above without affecting your reservoir. It is true that we use it for some other purpose, but this is the main. But all other landing nipples, the main reason to have it, please, it is to receive flow control devices. One day in my lectures, I have this question for the guys as a homework. The question says, what is the purpose of landing nipple? So I gave him choices. One of these choices is to receive a flow control device. Another choice is we use it for depth control. So one of the wireline supervisors, while answering this question, he selected for depth control, for correlation to depth. I said, thank you, but your answer is wrong. He said, come on, Ahmed. I'm a wireline supervisor for the past 15 years. And I'm professional in my work, and I am using the landing nipple to correlate my depth. I said, yes, I believe you. And I know that you are doing that. This is not the main reason we have it for. It is exactly when I go to the supermarket to buy milk for me. And then Dr. Ahmed Al-Garhi says, on the way back, would you please buy me a packet of cigarettes? I said, fine, no problem. If any of you guys ask me, Ahmed, where are you going? Should my reply, I'm going to buy the packet of cigarettes to Dr. Ahmed Al-Garhi? Of course not. I'm going to buy milk for myself. These packet of cigarettes I am buying for Dr. Ahmed, I am doing as a favor, but it is not in my job description. So remember that. A flow control device, we run it to sit in the landing nipple. A landing nipple main purpose is to receive it. If this landing nipple is doing 10 other things, yes, she's doing it as a favor. So a landing nipple is to receive and flow control devices. When we talk about two, which is circulating device, then automatically you should write SSD and SPM. SSD stands for sliding side door, and SPM stands for side pocket mandrel. These two devices are mainly to allow us to make circulation between tubing and annulus, or annulus to tubing. Annulus, it is the volume or the area between the tubing and the casing. We will talk about each one. Isolation device. The word isolation is welded to a word or to a device called Parker. And Parker is to isolate. The main reason for the Parker is to isolate. What you see here in this example, we have two Parkers. We have top Parker here, and we have bottom Parker here. This string of pipes and accessories, which its length might be 10,000 feet, 15,000 feet, 20,000 feet, which device here hold the weight of this whole string? It is a device on top here. We call it tubing hanger. But actually, the tubing hanger, it holds the weight of top completion only, while the bottom completion is hanging by another device. I mentioned top completion and bottom completion. What is that, Ahmed? I tell you that. Anything above the Parker, we call it top completion. Anything below the Parker, we call it bottom completion. The majority, of course, of pipes and accessories are on top. The bottom completion, actually, it's a couple of joints. Couple of pipes, joints, yani, each joint is 33 feet. And it has some accessories like perforated joint, wire and entry guide, a couple of landing nipples, and maybe permanent memory gauges. But this bottom completion, which is short compared to the total length of the well. Here, what you see here is the lower Parker. This lower Parker, and what's below it, this is the tailpipe, we call it. The tailpipe is the bottom completion. You see these short pipes. This is hanging by the Parker. But if I ask you, what is the main purpose of the Parker? And I give you choices. One of these choices is to hang the bottom completion. If this is your answer, I will dig a hole and bury you in this hole, because your answer is 100% wrong. Why wrong? Ahmed, you just said that while ago that it hangs. Yes, I said it does, but it does this as a favor. The Parker hangs the bottom completion exactly like me bringing a packet of cigarette to Dr. Ahmed while ago. I did it as a favor, but I was going down to go to the supermarket to buy milk for myself. So the purpose of the Parker is not to hang the bottom completion. The purpose of the Parker is to seal, to isolate. Isolate what? From what? If we don't have Parker, then we have this is our zone where oil and gas will come inside the well going all the way up, not through the production tubing only, but also through the annulus here, getting in contact with the casing. This will erode the casing and accordingly destroy the cases later on. So we have to prevent this oil from getting in contact with the upper casing. The upper casing, which is all the casing above the packer. Also, it is to isolate this annulus above it from the treating fluids. Because actually, when we start producing from a well, and let us assume it produces 1,000 barrels a day, but during the life cycle of this well, you will see that start producing 1,000 barrels, but by time it produces 950, 700, 600. Why? This declination of production. This is a big story, but there are so many factors affecting that. But one of them is because when you produce from a well, this reservoir downhole, it's grains, as we discussed in one of our lectures. It's grains, particles of sands, and there is a minor distance between each particle of sand and the other one, and you cannot see it by your naked eye. We said it's a microscope. So oil and gas is going through these channels that you cannot see it by your naked eye till it goes inside your well and it goes up all the way to the surface. By time, since there will be friction between an oil and these grains, particles, sand particles, this friction will reduce its velocity. Accordingly, some of the scales, the wax, the paraffins will sit on the outer surface of these grains, reducing, make it more narrow, these streets. So up till sometimes it blocks the streets down there. Oil cannot go through. If this happens, then you have to do some of the solutions here. Like we decided to do a stimulation job where we go, we run with cold tubing and we start pumping acid. This acid will penetrate these narrow roads or narrow streets, eating these paraffins, debris, waxes, allowing this street to become to the original. You don't have Parker here. The acid you are pumping through the tubing, part of it will not go into the formation, but it will escape out here, filling your annulus, affecting your casing, eating your casing. So the Parker is also to isolate the annulus from the treating fluid we are pumping. So Parker is to isolate. Keep in mind that. The anti-erosion device, we have two types. We have blast joints and we have flow coupling. The blast joint is what you see here in this drawing with blue color. Since we have one single completion in this example and we have two zones, so when we perforate the upper zone, if you see in front of this blue device, oil will come out from the reservoir, coming out with velocity. It hits the outside, the OD, the outer diameter of your production tubing. This hits, it erodes the OD of the pipe because it has sands. So these sands start doing like sand blasting. So this hammering effect on the outer side of the pipe, after some times, if this is our pipe, after some times, you will have holes here. If this happens, you have to stop production, kill your well, bring a workover rig, pull this completion all the way out to the surface to replace this damaged part of your production tube. and then run again. This will cost you a lot of money. So instead, to prevent this from happening, in front of the perforation, we put a pipe. Yes, but heavy wall pipe. It has the same idea of the pipe, but the wall thickness is higher. But remember, the same idea of the pipe, but the OD is bigger because the wall thickness is bigger. So it will resist this hammering effect. And instead of resisting 1 year, it will resist 3 years, 5 years, 6 years, depending on the material and thickness you are using. So this is the main reason of having this anti-erosion device. But anyhow, we will talk about both of them, not in this session, but in the coming session. Others, which contains all other accessories that we cannot classify it into these groups, 4 groups, like wireline entry guide, which is the last piece we put here in the tailpipe. We have perforated joints, we have control line, and we have tubing handle. This is mainly the accessories we use in completion. Completion is 2 parts. One part is mainly below ground, which is all these devices we talk about. The other part of the completion, which is above ground, which is wellhead and the Christmas tree. And although I am a mechanical engineer, and although I work all my life with international organizations, but believe me, for years, I didn't have the knowledge that makes me professional in my work. For example, for years, I was under the impression that wellhead and Christmas tree is the same thing. What is this? This is Christmas tree. What is this? It is wellhead. The same. Till I got the knowledge that there is a big difference between the wellhead and the Christmas tree, which we will talk about it in the coming session. So now let us start actually with our accessories. We start with landing nipple. So let us talk a little bit about landing nipple. What's landing nipple? Which is anchoring device. We said it is landing nipple. Tubular, short pipe. And it has 3 features: shoulder, seal bore, and profile. What you see here in this drawing, this is a landing nipple. And you see what I wrote here? All landing nipple is to receive a flow control device, as we agreed, except the last one, it is to isolate reservoir from the lowest possible point, although it does the same also. It allows us to receive a flow control device, but this is not the main reason like the others. Any landing nipple, it is shoulder, it has 3 features: shoulder, seal bore, and profile. Please remember, this is not a completion course, because if this is a completion course, what I'm saying is wrong, because we have landing nipple that they don't have shoulders. Then I have to go with what we call selective landing nipple and non-selective landing nipple, but this is not the course about that. Generally, any landing nipple, it has 3 features: shoulder, seal bore, and profile. The aim of this course, what I need you to know about the landing nipple is 2 things: why we use it to receive a flow control device, and how we use it. How we use it is by utilizing these features. How? What we do is, let us assume that we have a plug in our hand, and we need to run this plug inside the well, and we're going to set it in the last landing nipple downhole. Here. Let us do that. Let's have slickline people. They have the running tool and they start running the hole. This plug, which is designed to be set in the last bottom landing nipple, will go through all these landing nipples. You see it in the diagram, but none of them will identify it because of sizes. Till it reach the last one, then the shoulder, which is inside the landing nipple, will identify this plug. He will tell this plug, stop. You are mine. You will not go. You will not go. This is the reason of the shoulder. So why you have shoulder? It is to guide, to enable, to locate. These are three key factors we use: guide, or enable, or relocate. A flow control device that we run to set in its matching profile. Because if this is the landing nipple, you see it here, this is here what we call a profile, which is a profile inside the IDU to allow the mechanical device that lock the flow control device in its nipple. This is what we call the profile. So the reason of the shoulder is to guide, or to locate, or to enable the flow control device to set in its matching profile. Because the moment the shoulder stops the landing nipple, this flow control device, which is the plug in our case, it has what we call dogs, which is a mechanical device, spring-loaded, that when you set it, these dogs are exactly in front of the profile of the landing nipple here. So the spring will push it out to make these dogs set correctly in the profile. Now the device is locked in the place, locked in its landing nipple. So this is, the shoulder is to allow or enable, guide, locate these flow control devices we run to set in its matching profile. The profile of the landing nipple with the dogs, or the lock mandrel we call it, of the flow control device, it locks the device in place. So we identify the location, what makes the seal is rubber packing. Any slick line tools we run, it has external packing, external rubber. We call it elastomeric packing. This elastomeric packing, it's sealed within this seal bore or polish bore. Polish bore or seal bore mean polish bore. This bore has to be very smooth, like this glass, very smooth. No grooves. If there is a groove, it will not seal. And this is, I believe all of you guys knows the Okandi, the Gulf of Mexico disaster, where people were drilling in that. I don't want to go through this, but anyhow, when the driller feels that there is a problem, where we run almost 3 miles, and with drill pipe and drill cooler, and the pressure was able to overcome the mud weight and overcome the hundreds of tons of this drill pipe and drill cooler and push the drill pipe and drill cooler upward. He closed a device to seal. This device, which we call annular DOB, it's rubber that seal around the pipe to prevent an escape of pressure. But the pressure is very strong And I say that it is very smart as well. Very smart in the sense that when the pressure fights with you, he always tries to find your weak point. And he finds it by default and attack you from your weak point. So when the driller closed the annular BB on the drill pipe, pressure tried to escape, but it is locked now. So what pressure did? He started eroding the OD of the surface of the pipe, making the groove, very tiny groove. Because rubber will not be able to seal if there is grooves. And he did it and escaped from this narrow groove. The seal, or the rubber of the annular BB didn't help now and escape all the way to the surface, to the direct floor. So that's why it has to be push bore or seal bore. Landing nipple is to receive a flow control device. How it works? It has the shoulder to allow to guide, to locate this flow control device to its matching profile. The reason of the profile, it is with the dogs of the flow control device, it clocks the device in place. What makes the seal is the elastomeric packing, external packing that sits within this seal bore or push bore as we agreed. Now the device is set correctly and preventing the escape of oil. What you see here is a landing nipple, but we call it SV nipple. SV stands for safety valve nipple. Because this particular landing nipple, it has a certain features here. You see it? You see here? These features? These features is to connect what we call control line, which is stainless steel tube, 316, quarter inch in size, in diameter, and it is all the way to the surface. You can see it in the drawing. You can see it in the drawing. It goes all the way, this control line, all the way to the surface, where in the surface we have a control panel, which has a pump, where we can pump fluid to activate the downhole city valve, which is set nipple, which is the first nipple in our completion, where we set the downhole city valve in it to able to control the well. Okay, since we are sitting in this landing nipple downhole city valve, and the downhole city valve is one of the barrier, and we call it, if you remember, emergency barrier. We need to talk a little bit about the downhole city valve. So let's talk about the downhole city valve. We have two types of downhole city valve. In the past, we have what we call PASSV, which stands for pressure activated downhole safety valve. And we had two types of that valve, ambient pressure and differential pressure type. When I talk about this type of valve, I use the past tense because we stopped using these valves from last century. 1986, 87 maximum, we stopped using them. Why we stopped using them? Because they create problem for us. Actually, this type of valve, like differential pressure type, this valve, we run it in the hole, but in the surface, we preset it to open at a certain differential pressure. We run it with the slick line, we run it open, all the way to the below the packer, who will be sit in the landing nipple there. It's open, and then we are producing from the well now. If the downhole pressure, the bottom hole pressure changes, accordingly changing differential pressure, this valve will automatically shut off the well, securing your well. Solve your problem. If you need to reopen this valve, what you do is pump pressure from above to bring this differential pressure below and above to the preset, and then this valve will open, so you can start producing from this well again. Great, Ahmed, what you see is very nice. We don't see the problem. The problem is that, I believe you agree with me, that the bottom hole pressure is never constant. And if I tell you that this particular well, the bottom hole pressure is 3,000 psi. Do you believe it is 3,000 psi, 8 o'clock in the morning, 10 o'clock in the morning, noon time, afternoon, evening, tomorrow, next week, next month, next year? Of course not. The bottom hole pressure is always fluctuating. It goes up and down like that. Up all the way during the hour, during the day, during the month, during the year. This valve does not understand this. The moment there is a change in bottom hole pressure, accordingly there is a change in differential pressure, it shuts off. Even if the situation does not require you to shut off the valve. So every time it shuts off, you stop your production, you have to bring a pump from above. So it's waste of money and waste of time. You don't have the control on this valve, when to open and when to close. That's why these days we are using the other type of valve, which is SCSSV. Stands for Surface Control Subsurface Safety Valve. The valve is still subsurface because we have to protect it from yourself. We have to keep it below the ground. So you cannot play with it wrongly. But this time, this valve, we control it from the surface. I am the upper hand. I can close the valve the time I want, and I can open the valve the time I need. And we have two types of that. We have wireline retrievable safety valve, and we have tubing retrievable safety valve. Well, we might go quickly through them to talk about it. And, but before we go to other slides, the next slides, please look at what I wrote in green. Valves works by pressure. All these downhole safety valves, they work by pressure. They don't work by temperature. They don't work by pushing. They don't work by nice words. They work by pressure. And I have two closure mechanisms, only two. Either bowl type, bowl that open and close like that, or flapper type that open and close like that. I have no other types. So please, when I ask you a question, what are the two closure mechanisms we use? Please, don't take on gate valve, or hammer valve, or puppet valve, because we don't have such mechanism. The common one is bowl or flapper. Let's talk about the first one, which is the wireline retrievable downhole safety valve. If your selection is to run wireline retrievable downhole safety valve, this is the valve itself. Very simple in construction, as you see, it's body, which is blue color, and then we have the red color is the lock membrane or the dogs that's spring loaded, that the spring push it to sit in the profile of the landing nipple, and we have here the packing, which make the seal with the seal board of the landing nipple. What we have inside is piston, spring, flow tube, and flapper. The flapper is one of the mechanisms we talk about that open and close like that. If your selection is to run this, so what you do, you run the completion, and while running the completion, you run the landing nipple of this valve. Once you run the completion, you go to the slick line operator, would you please come and run this valve and set it inside the landing nipple. This is the landing nipple, what you see here. This is the landing nipple that we run inside the well. It is part of the completion, fix it to the completion, and then this is how you see it. This is now what we have here. We have this valve, this downhole safety valve. It is inside its landing nipple. It is set there already. And what you see here, these are the dogs, which is inside the profile now to lock. And we have these packing, one above this hole and one below. These are the packing, one above and one below, to allow us, when we pump this fluid inside this tube, stainless steel tube, which is the control line. So this fluid goes inside here. What allowed this fluid to enter the valve, it is these two packing. He cannot go there, he cannot go there. The only space for him is to enter the valve. Enter the valve, pushing the piston, which is green color, downward. So the piston pushes the spring, pushes the flow tube, which is a piece of pipe. When you push it down, it pushes the flapper, which is closed by default by spring washer, spring here, that if there is no pressure on the valve, this spring will push the flapper to keep it closed. You can apply pressure from above, it opens. But from below, it locks. So since this flow tube is pushed by the piston, which is pushed by the pressure, it pushes on the flow tube, on the flapper, open it. As long as the pipe, if this is the flow tube, as long as the flow tube is in this position, the flapper cannot move this direction unless you bleed off the pressure above. If you bleed off the pressure, this spring will retract, pushing everything upward. The moment that this flow tube is out, the spring here, it locks. This is how the mechanism, very simple idea actually. This is how the mechanism works. In the past, I used to say that what we pump here, it is hydraulic oil. Till the moment I discovered what I'm saying is wrong actually. It has to be a fluid compatible with the location supply. Because actually, I cannot, as a vendor, as a manufacturer of downhole city valve, and supply you with a downhole city valve, and then tell you, okay, this is the fluid we are using to open and close the downhole city valve. And then I gave you a couple of jars full of this oil, this fluid. Then you start using this fluid till it is finished. Then you need more. Then you call the manufacturer. Okay, would you please send me 2 bottles of this fluid? Then the guy on the other line will tell you, okay, no problem. I record your name and your mobile number. Within 6 months, you will have this bottle. Come on, why? This is special fluid. We manufacture it in our factory, which is in the moon. So our next spaceship going to the moon is next month. By the time it goes to the moon and then come back, it takes time, of course. So 6 months you'll have it. This is crazy, right? What I'm saying is comic. So actually, this fluid should be compatible with location supply. If it is finished, I don't have any more, then I'll go to the mechanic. Would you please give me some gear oil? It will work. Would you please give me some hydraulic oil, ATF oil? It will work. the mechanic doesn't have, then you pass by the kitchen. Go to the cook, would you please give me some seed oil, some corn oil? It will work. Compatible with location supply. So I cannot stop. Because if the downhole city valve is malfunction, if it's not working, first thing is to do is to stop your production. You cannot produce from a well which does not have a working downhole city valve. So it has to be compatible with location supply. This is how it works. Any particular time, at any particular time, you need to stop production. All what you have to do from the surface, bleed off the pressure. So when you bleed off the pressure, there is no pressure above this piston. So as I said, the spring will retract, pushing everything up. Downhole city valve, the flapper will close, the well is secured. So now the flapper is secured, the well is secured, you solve your problem. Now we need to open this downhole city valve. How to open it again? Should I repeat the question? Now, during the production, we have a problem, we bleed off the pressure, we shut off the valve, we secure our problem. Now we need to reinstate production. So first, we need to open this valve. So to open this valve, how we open it? So people tells me, Ahmed, go to the control line, apply pressure to this control line to open it. Crazy, you cannot. This valve, which is closed now, it has a differential pressure on it. Below you have 3000 psi, above you have 0 psi. You cannot open a device which has a differential pressure. What I am saying is generally, of course, because we have devices that we can open at 15,000 psi differential pressure. But generally, you have to equalize the pressure. To work safe, you have to equalize the pressure. So this is closed now. To open this flapper, first you have to apply pressure from above to equalize the pressure if it is not self-equalizing type. Yani. So pressure here is the same as the pressure here. Now you can apply pressure to the control line to open this flapper. A question. Now we run the completion, which includes the safety valve and nipple, and now you have the wire line to run this downhole city valve to set it in the tube. How the wire line will run this downhole city valve? Keeping in mind that when you are in surface, this system inside is upward and the flapper is closed. You cannot run this valve while the flapper is closed. Why? Because what's pressure? Force divided by area. What's force? It's pressure times the area. So when this is closed, the force you have while running in the hole from the fluid is along all this area. You will not be able. This has to be open, so you minimize the area. So you minimize the force against this valve open. So people say, okay, control line, go to the control line and pump, so it's open. If I go to the control line and I have the valve in my hand and we start applying pressure, I will stay in this position for 3-5 years. Nothing will happen because this pump is attached to the control line, which is attached to the landing nipple, which is 300 feet downhole. It's not attached yet to the valve. So I cannot. What to do? We use what we call prong. Prong, P-R-O-N-G. The prong is a bar, it's a bar, steel bar. I attach it to the running tool. So when I am running now, this bar is pushing this flapper to keep it open. all the way till I set it in place, and then release the running tool from the valve while pulling up of the hole. The moment the prong is out, the flapper will close. This is how we run it open. One more thing you have to know, that during emergency, if you need to shut off this valve, we agreed that we bleed off. When you bleed off, the system goes up. The system goes up, pushing the fluid inside the valve and inside this stainless steel tube all the way back to the tank. This is the return. This volume has to be monitored. The return volume has to be monitored. Why? Because this is one of the reasons that tells you if the valve is closed or not. Because if in normal situation, when you bleed off the pressure, the amount of return fill this glass, but today, when you bleed off the pressure, the return it fill half the glass only. That means what? Valve is still open. That means while the system, while coming out, it didn't go all the way up. It goes to the middle, somewhere in the middle, and stop. Most probably the flow tube is stuck and didn't continue pulling out to the original position. So knowing the return is one of the functions that tells you that the valve is not closed. Be careful. If you decide to run not wireline retrievable, but tubing retrievable, this is the tubing retrievable. The tubing retrievable, it is the same mechanism. Most components are the same, but this type we run it with the completion. It is part of the completion. It is fixed to the completion. So this is nice. And instead of the wireline, we have to make two runs. You run the tubing and you run the landing nipple, and then you run the valve separately. But here it is one run, because the valve and its landing nipple, it is one body, two in one. Same component, but here I have a problem. I have a big problem. If the wireline valve fails, I can send the wireline people, we go, grab it, take it out, fix it, put it back. If this one has a problem, wireline people can. Actually, you have to kill the wheel, bring a workover rig, and then pull the completion, kill the wheel, pull the completion to change it or to repair it. So, if it has this big disadvantage, why we use it? Because actually it has one single advantage over the wireline from our point of view, which is if you have two valves, one is wireline retrievable and one is tubing retrievable, the same size, the tubing retrievable ID is larger. So I used to use this valve in very low pressure reservoir, telling the oil, do not worry, Mr. Low Pressure, while going up, traveling all the way, there is no restriction. So you can go all the way up, safe. And actually, I use it in the opposite. I use it in a very high pressure reservoir. Why? Because actually, if we go back to this is the wireline retrievable, while producing the oil and the gas is going here, what stops this annulus? It is the packing. If in high pressure gas runs, this gas, it attacks the packing and it eats it. Here in this design, we don't have such a packing because this is not retrievable. I don't have to pull it and put it back. That's why it lasts longer. actually, the life of the wireline retrievable, it is between 18 and 24 months, where this tubing retrievable can last up to 20 years. So that's why, but from our point of view, it has the big advantage from our side is the ID is larger compared to the wireline. This is the tubing retrievable. When it is closed, you see the flapper is locked, and this is while open, so you can produce from it. Why, Ahmed, you are not talking about all these topics? It's there because this is a simplified course. Yeah, I don't teach it to you guys, but I can teach it in other courses. Yeah. This slide, it tells us the story of downhole safety valve in one slide. We have two types of downhole safety valve: surface control and subsurface control. The subsurface control, we have two types of it: ambient and differential. And remember, we stopped using this type from last century. What you are using now is the surface control, which is wireline retrievable or tubing retrievable. In wireline, how we run it open, we agreed with this sprung, this bar, steel bar we attach to the running tool. But a tubing retrievable, we can use the control line because the control line is fixed to the valve. So you can use control line. And we have another option which we call it straddle set. The straddle set is a piece of pipe, short pipe. When we can run it by hand, when we are on the surface, we put it by hand across the sleeve here, across here, pushing the flapper to keep it open. So as long as this short pipe is inside this profile, the flapper cannot be closed. And after we run, then we use the wire line to retrieve this straddle of this piece of pipe again. So the tubing retrieval, we have two methods to run it open: either the control line or the straddle set, while the wire line, the only way is use sprung. The first devices we talk about, the first group was the anchoring device, which was the landing nipple. Then now we talk about circulating device. Circulating device, we have two devices. We have SSD, sliding side door, and SPM, side pocket control. Let's start with the sliding side door. What you see here is a sliding side door. It's a short pipe, but this short pipe have outside, and inside it has a sliding door which is brown color or orange color. So if this door is closed, there is no communication between a tubing and an annulus. If we need to establish communication between a tubing and an annulus, we run the wire line, the slick line, latch on top of this door, and then start jarring, whatever jarring up or jarring down. When jarring, let us assume that this is jarred down to open. So the moment this shifting tool will latch on this sliding door and keep jarring down, keep pushing it down all the way in. Now these ports are open, allowing the communication between annulus to tubing or tubing to annulus. This is the main reason of the sliding side door. It is to allow this kind of communication between tubing to annulus or annulus tubing. What I need you to know about these devices, why we use it, to establish communication. Number two, what should we do before we open it? We agreed that you cannot open anything unless you apply the pressure. So this pressure has to be equalized between a tubing and an annulus before you open. Number three, when you open it, you have to be sure it is fully open. Because if it is partially open and you start pressure circulating, this door sliding door will start to shake, to have like this vibration. This vibration might affect the seal that prevent the leak when you close. If this happens and you damage the valve, you damage the sliding door, you have to kill the wheel, bring a workover rig, pull the production. It is hassle. It's a lot of money, waste money. Again, this valve, this device, sorry, it is for communication. Before you open, you have to equalize the pressure between the tubing and the annulus. Number 3, you have to be sure it is fully open. Number 4, when we put it at what depth? If you look at the drawing in front of you now, someone will tell me we put it above the parker. I said wrong, because if it is above the parker, this is the parker. So if I put it here, this is above the parker. If I put it here, this is above the parker. If I put it on surface, this is above the parker. You are engineers, you have to be precise in what you say. So a gentleman told me, okay, Ahmed, just above the parker. I said wrong. Why? If you put it, if this is the parker and you put it just above the parker, and during the life of the well, you have fluid in the annulus between the parker, between the production tubing and the casing. If you have any debris or scale settling down on top of the parker, it will block this door. You try to open or close it, it will not. That's why we put it one joint above the parker. It's almost 30 feet above the parker. So even if the fluid on the annulus settle down this debris and scale, you still away from the SSD. You can freely open and close. So you put it one joint above the parker. In this drawing in front of you, in this sketch, you have 2 parkers. Why you have 2 parkers? Because you have 2 formation. So you have 2 parkers. So where we put our SSD, we put it one joint above the parker. Where we put the second one, we put it between the 2 parkers. But the one we put between the 2 parkers, you see it, it is not for circulation or communication. This is for production. If you need to produce from the upper zone, you open it. If you don't need to produce from the upper zone, keep it locked. So, number 2, equalize the pressure before opening. Number 3, be sure it is fully open. How do we know Ahmed is fully open? Because when you start jarring down, if it is jarred down, for example, the moment you lost the jar and your tools goes all the way down, it is fully open. Number 4, we set it one joint above the parker. This is for communication or circulation, or between the 2 parkers as we agreed for production. The other type, which will be the last topic today, is side pocket mandrel. Side pocket mandrel, it is a piece of pipe, short pipe, but it has a belly, as you see. There is a belly. It's like the pregnant woman. Because in this belly, I put here a valve. We call it gas lift valve. We normally use this device for in wells where it does not produce naturally, and it needs an artificial lift technique. And the technique I decided to use is gas lift, where we pump the gas, we inject the gas in the annulus here. It goes through these ports, passing by this gas lift valve inside the tubing, pushing the oil up. But sometimes, some application, I run this device in natural fluids. Why? because I have a vision. From my study to the reservoir, I know that this well will flow naturally for maybe 6 to 7 months, then it will need an artificial lift. So from day one, I make my design, I have it, and then the moment I need it, I go there, and instead of having what we call dummy valve, so this one is not working, a dummy valve, it's a plug. I remove this dummy valve and I put gas lift valve instead. The reason for these side pocket mandrels is to use it for artificial wells. Artificial wells where our technique is to inject gas. Gas we inject it from the annulus. It goes through the ports, passing by the gas lift valve. Where this gas lift valve, inside it we have a check valve. This check valve allowing the gas to go from the annulus inside the tubing, but not vice versa. It's one direction, from annulus to tubing. If you don't need to start with this kind of communication, you go, run with the slick line, remove this valve, and put instead dummy valve or plug to prevent circulation. But what if I need to inject chemical like corrosion inhibitor inside the tubing? So I'll pump corrosion inhibitor from the annulus to the tubing. So please remove the gas lift valve and put what you call circulating valve. We put what we call chemical injection valve. And this chemical injection valve, inside it, there is a gas lift valve, preventing the vice versa, the movement from tubing to annulus. If you need to kill the well from the annulus, remove this valve and put, please, differential kill valve. Put a kill valve. And this kill valve, it has a check valve preventing movement from or circulating from tubing to annulus. Ahmed, if all these valves you mentioned, gas lift valve, circulating valve, chemical injection valve, differential kill valve, all these valves, they have a check valve preventing the movement from annulus to tubing. Why we use all of them? Yani, keep please the gas injection valve and do whatever, kill from, circulate from, inject gas from, inject chemical from this kind of valve. My answer is no, big no, you cannot. Remember, a gas lift, any device you use to deal with gas, keep in your mind, this is very expensive device. So it is not correct to use a very expensive device and you spoil it in an operation that needs a very cheap valve. And who told you that these gas valves will resist the chemicals you are pumping? If you are resistant chemical, you have to use a valve that it is suited for chemicals. It will not be affected by chemicals. So we can set in this profile. We can set gas lift valve, chemical injection valve, circulating valve, differential kill valve. A question came. The question says that you need to kill this well. So what you did, you remove the gas injection valve and you start circulating from the profile itself. It looks like, in our example, he's supposed to put differential kill valve, but he doesn't have on location. So not to damage the gas lift valve, he removed the gas lift valve, and then from this profile, the hole, he will kill the well. And the question telling you what precaution I should do while killing or while circulating from the profile. This is not correct. This is not a correct operation, but you are forced to because you don't need to damage your valve, which is the gas lift valve. The precaution you should do actually is, while circulating, please minimize your speed. Because if you circulate at a high pressure, which means high velocity, this high velocity fluid, while passing through this profile, it will erode it. This friction, this high friction will erode it. So you have to pump at a slow rate, minimizing the erosion of the profile itself. I have been talking for 1.5 hours almost now, which I hated because I don't need my lecture to exceed 1 hour. So it will be nice and easy for you to swallow instead of listening to a laptop for 1.5 hours. So I will shift the remaining part of today, which was the Parkers, to the next session. And I will try not to go in details like I keep doing it. I will stop now here, and we'll see you, I think, within 3-4 days for the next session, which is completion again to finish it. And Hassan, I'm done. If you have any question, if anyone has any question, I'm ready for it.
Thank you so much, Engineer Ahmed Elzeftawi, for the very well explained and nice lecture. We do have got the questions. A student is asking, what type of packer do we use in completion of the well?
What kind of Parkers?
Yeah.
This will be discussed not in this session. This will be discussed in the next session, but we use production Parker. Production Parker have different type. We have permanent, we have retrievable, we have permanent retrieve, but this will be discussed in the next session.
Oh, okay, great. Another student is asking, what is selective and non-selective landing nipple?
This is not a question to be asked in well intervention, but yes, we have two types where one has a shoulder and the other one has no shoulder. The one that has no shoulder, it has another technique of setting these flow control devices in it. But I don't want to go through this here in this particular course.
Okay. A student is asking, can you recommend us a book for the well intervention?
I will send it to Dr. Ahmed. So he can distribute it to you guys.
Okay, thank you so much. One last question. If we have two packers, in that case, from which point lower completion starts?
The lower formation, on top of it will have the lower Parker. Then the upper zone, on top of it will put the upper Parker. If this is the classification he is asking for, if I understand the question correctly. Hassan?
Okay, thank you so much. Thank you so much, Engineer Ahmed Elzeftawi. It was a very interesting and informative session. Guys, if you have not joined our Google Classroom, join it, because only then you can access to the quizzes and final exam, and you can have a certificate at the end. If you fail to join our live stream Zoom session, there is nothing to worry about. We will upload the recorded session on our YouTube channel, PioPetro. Thank you once again, Engineer Ahmed Elzeftawi. It's a pleasure that we have you for more sessions as well. Please take care and stay safe. We look forward to seeing you again.
Thank you, Hassan. See you guys. Bye.